Hello everyone, welcome to the 9th point in this series on how to create your very own multicolored research-based Go playing program. So in this video we'll provide some helper functions to work with multicolored research algorithm. For instance, copying the board, the isGameOver state, and generating candidate moves for the multicolored research node selection and expansion phases. So I've made some changes in the code. Well, essentially, I've already drafted the very initial implementation of the multicolored research algorithm, and yeah, it even did manage to sort of search some moves, which is cool. It's still slow as hell, and really lots of improvements is needed. But I've already managed to come up with a reasonable framework to kickstart with. So the framework that we can work within with an idea of improving the engine. So we'll kickstart with an update in the source code since the last video, and then we'll write these helper functions. So without further ado, let's get started. So part 9 code is not exactly the copy of part 8 code, so let's have a look at those things has changed. So the concept of the last move has been added. So now within the board, so this is just a simple variable. So last move, integer. So within the init, we initialize the last move to empty, all right? And also, when it comes to playing the move on board, so if the move is true, we set the board last move equals to square to the move that has been played, the very last move has been played. This is going to be used within the multicolored research. So this is very simple, like self-explanatory kind of stuff, so I didn't want to do this within the video to avoid any confusions, so any typos, weird typos and things like that. Okay, next update, layout of genmove and the renames of the functions. So earlier playouts were in the section of the multicolored research, but I thought that it's more reasonable to put them into a board. Into the boards section. So within the board section, now we have this board pointed to board playout. It was multicolored research pointed to multicolored research. Earlier now it's board pointed to board. So we can do board.playout because this makes sense because the playout would be associated with the current board state that is encountered in the within the multicolored research. So this makes more sense. I have no idea why I did this differently. I don't know. So now playout is essentially the part of the board functions family. And also within the heuristics, I've renamed the function genMove to generate playout move because we'll also have the function to generate candidate moves. So playout moves and candidate moves, although they, well, at least for now, they would be sharing like sort of a similar logic, but they would be sort of similar. But again, from the perspective of functionality, yeah, like in purposes, they are really different. So generate playout move is the matter of the engine like makes the player from the current position to the very end and return the either one if black wins or I mean yeah, sorry, that's regarding the playout. So playout is relying on generate playout move, and board playout would result in either one return 1 if black wins and -1 if white wins. So and the board playout would be calling and is calling generate playout move. While within the multicolored research would be calling the generate candidate moves. So those are kind of different. So again, with the playout, we just do this generate playout move here. Yeah, hopefully this makes sense. Now, just right above the playout, we would be inserting a couple of functions. So yeah, I think from here we can already start. So the first function, like one of the most essential ones, is the function to copy the board, to create a deep copy of the board. So we do function, define a function board pointer to board structure, and just call it copy, and this would be returning a pointer to a newly created board structure. So I define the board copy variable. This is going to be equal to the new board. So we can start with just creating a new board. And then we need to copy all those fields we're interested in. So board copy and dot size is equal to board dot size, right? Then board copy side is going to equal to board side. Then board copy co is going to be equal to board co. Okay. Board copy last move equals to board last move. And for the position, the main part, the board position, we say board copy position equals, so want to make a new slice here. So the slice of type integer, and the size of the slice would be the length of the board position. All right. Then we want to copy, so I do copy to the board copy position. I want to copy the contents of board position, right? And finally, after all this, we just return board copy. Let's make sure this sort of compiles and runs still. So go build and go. Okay. Yeah, also, by the way, I got rid of the debug function, which was holding some temporary code. We don't need that anymore. Okay, let's test the board copy. So for instance, so we just created a new board. We can do now board.playout. And then we may do board.show. So I want to alter the stage of one board instance. So board instance after the playout looks like this. So we'll be copying the board and making a playout. Okay, so we'll be making a playout on the board copy. So for instance, I can do the following. So I can say board copy equals to assigning the value of initializing the value of board copy. Okay, then I want to do board copy playout, board copy show, and also I want to do board.show. So the idea is that we just created a board copy and we did a playout and we show what is there, the result. And then we show the original board. And since this is a deep copy, it's not a pointer to the original structure. So the original should be empty board because we didn't do literally anything to the original one at the moment. So we do play out on a board copy. Let's quickly check this out. Okay. So, and exactly the thing here. So this is the board copy play out being finished. And this is the original board. Yeah. So here it's like really clear and nothing is there. Okay, great. So now let's go further on. Yeah, also, yeah, I forgot to so get rid of this. So playout move to board. Yes, and updating the GTP gen move. So essentially in gen move, I got rid of, so first is changes that now it's not board gen move, but board gen playout move. That's temporary, and I also remove the loop to do this like 1,000 times. It does negatively affect the way how we place. It would be passing early, but this is just a placeholder because instead of this, we would be calling the multicolored tree search later, right? So, so this is another minor update. Okay. let's go back to so I want to find the board copy. Okay, so here is the board copy. Okay, another function I want to create is the isGameOver function. So I say function and board pointer to board and call it isGameOver, and this would be returning the Boolean value. Okay, either true if game is indeed over, or false if not. And here we do quite an elegant trick. So I return the length of the board that generate candidate moves. We don't yet have that function of the generate candidate moves. Okay, and the condition whether this equals to 0 or not. So if the board that generates candidate moves returns 0 moves, so the length is equal to 0, this means that the game is over and multicolored research node expansion phase terminates. Now we move down below to the heuristics section, and after generate playout move, we will create the function generate candidate move. Okay, so here would be the function board pointer to board and generate candidate move. Sorry. This would be returning slice of integers. Okay, so I create moves variable which is the slice of integers. Okay, then this is going to be just a placeholder for now, but anyway, we can do for index and move assigns the range of, and we can initialize this on the fly. So let's give the corner values, so corner 1, corner 2, corner 3, and corner 4. Okay, so this would be generating corner moves if available. If it's not available, that would be just skipped. So this is like pseudo-legal moves. These are not the legal moves, okay? So make move would reject the move if it's not okay. Then we want to append to the moves. So I say moves equals to append. I want append to the moves, and I want to append the move, which would be the value of 88, 340, 352, and 100 sequentially. Okay, and we also can probably do this like so. Next thing, so just like we did over in here, so having the engine and player moves. So here we don't care whether it's engine or player. We just want to, again, just for now, we just want to find those weak groups, smallest groups, and liberties of those small groups. And those liberties of those small groups would be considered as candidate moves. Okay, so I can simply say, again, for index and move, and assign the value of the range of board, find the smallest group, target, and for black color, so we just list the color here, and here I just do moves equals to append and append moves, and I want to append the move, right? And similar thing done for whites. It's very simple, very straightforward. Okay, and finally want also to append some random moves. Moves equal to append to moves, and I want to append board random. For now, let's do no higher than number. like no higher than second rank, no lower than second line or second rank. So to avoid plain in the edges. Well, again, this is just a placeholder for now. Finally, want to return moves. So now let's check this. See if it's still compiles and runs. Okay. Yeah, we're just generating a player. Good. So I don't want to do any of these for now. I want instead to do fmt print line, and here isGameOver. Yeah, isGameOver, and the board isGameOver. And now it should be equal to false, because it should now be capable of generating moves. So isGameOver is false. Okay. But if we do isGameOver, no, not isGameOver, candidate moves. If we just return an empty slice here like this, then isGameOver int a equals to true. So this is how we're supposed to be distinguishing these two. So here I just undo, and yeah, essentially we are done. And starting from the next video, it would be one of the most exciting parts within the entire series, at least for now. We'll implement the multicolored research, all the 4 phases: selection, expansion, simulation, and backpropagation of the scores. We'll obviously create a multicolored research node structure and how to deal with that as well. Okay guys, this is it from my side. Thanks for watching, and I'll see you in the next video. Until then, and cheers.